Thank you, Colin. That was great. And now we're gonna have Matt's Rynge talking about the perfect match between Pegasus and OSG. There was so much spoken during these 2 days.
There we go. Okay, so yes, so my title here is Pegasus and Open Science Grid, a perfect match. Full disclosure, I'm paid on both of these projects, so I have multiple motivations for giving this talk. But if there's one takeaway here is that this match, right, where Pegasus and Open Science Grid is a match each other, it's very mutual. And what I mean with that is that if you are a Pegasus user looking for a good execution environment, Open Science Grid is a great choice. And part of that is it's HTCondor based. It feels like a very native home for Pegasus to use. But this, again, this goes both ways. Open Science Grid being a distributed environment, there are some challenges such as how do you manage data? How do you transfer data back and forth? And that Pegasus is a great tool to help with that problem. So that's the main takeaway. And I'm going to talk more about the data challenge and a little bit, so give some hints on how use Pegasus on OSG. And when I talk about OSG here, I'm mostly thinking about OSG Connect, and this is the hosted service that Open Science Grid provides. It's really for kind of small to medium projects that do not have infrastructure themselves. They can come easily sign up and get an account in this hosted infrastructure. It's hosted submit host, hosted data infrastructure, and it's open to all US researchers. So it's a really good resource for you if you looking for execution environment. Now, when I'm talking about the distributed nature of Open Science Grid, this picture here on the right is really good to keep in mind. So on the left, we have the submit host where we have a workflow that we're planning and we're handing to Pegasus. And these jobs then go to different Open Science Grid compute nodes. And it being distributed, being in different parts of the country, it's part of the job is to do data management. It has to pull in the data it needs to use, do the computation, and then stage out the output data back into some kind of common central data location. So that's what we're seeing here on the left, where we have inputs going into the job executes, outputs getting staged out somewhere else, and then that maybe is an input to another job, that job runs, and then outputs goes out somewhere else. So keep this picture in mind as I'm going through the next couple of slides here. This slide is kind of for the hints that I was talking about and mentioning a few of the data transfer mechanisms that's available to you on Open Science Grid. And the first one here is Condor.io. This is well supported in Pegasus. It works great for, again, smaller to medium pieces of data. The data gets transferred with the job, so it's very easy to set up. There's no need for extra credentials or anything like that. A step up from that is stashcp, and this is if you have any kind of data reuse in your workflow. We talked a little bit about this yesterday in the Event Horizon telescope case. Stashcp is actually a really good choice. So the idea here is that you put the data into the stashcp, and there's like an automatic caching mechanism underneath that makes this data appear close to where the jobs are running. You can also transfer data back with stashcp and using this SciToken authentication. And OSG Connect, this is all automatic. Every job that goes from OSG Connect carries a SciToken that enables this. SciToken and the stashcp and SciToken support, again, natively supported in Pegasus. So it's a great choice. And if you do the Pegasus tutorial on Open Science Grid, it's based on stashcp. So that's a good place to look. And then we have some other protocol. I have WebDAV in here. Again, Event Horizon used it. But it's also the basis for something new that's being used or kind of showing up in Open Science Grid. And it's this protocol here, like it has a couple different names, but a lot of times we hear it as HTTP-TCP, and that TCP is third-party transfers, or TPC. It should probably be TPC, third-party copy. I probably got that wrong. So it's HTTP-TPC for third-party transfers. And this is basically a replacement for grid FTP, where you can say, you can sit outside and you say, I transfer from point A to point B, and you don't have to have the data going through the initiating connection. So that's going to be a solution for grid FTP replacement. We also have support for S3 and grid FTP. Those are limited support or being phased out, but Rusio is still a big part of Open Science Grid. We do not have native support for Rusio, but a lot of our users are using it in the jobs themselves, and that's a good solution for this. So a little bit about Stash Cache, because it's just it's good to understand a little bit on how that works underneath the covers. And the main thing to know is using GeoIP to know where the closest copy of a piece of data is. So your job is running down here somewhere, and everything above here you don't really have to worry about. That's automatic. But stashcp or stashcache will look for a copy close to where the job is running. If not, it will start populating caches going up the chain until that data appears. If you have any kind of data reuse in the workflow, stashcache is a great solution, as it will speed up your data transfers a lot. And if you look at this from an Internet 2 and scenic kind of point of view, this is a lot of the data that you are transferring on Open Science Grid would go over these networks. And so you can see where we have these caches, San Diego, Caltech, and then up here in the northeast. And what these are, they are very kind of strategically placed, right? You can see that a lot of places share connections with, for example, the cloud providers or other network providers. Are also strategically placed based on where a lot of the compute resources in Open Science Grid are. So again, there's a lot of effort that goes into providing this caching infrastructure. Another thing that we have mentioned during this meeting, but we haven't really gone into, is automatic integrity checking in Pegasus. This is happening automatically, and you don't really have to worry about it, but it's a feature that I think is a good value add onto Pegasus. And go back to this picture where we stage data back and forth, right? Like all this data staging and data storage, is a potential point for data corruption to happen. So what Pegasus does is these little blobs that are before and after the job is, before it uses a piece of data, it does an integrity check. And after it's produced a piece of data, it does generate a new integrity checksum that then can later be checked in the next subsequent jobs. So again, this is happening automatically for your workflows, and if it finds an integrity error, it will retry the jobs. If it still can't make any progress, the workflow will stop there. The last thing I want to mention is containers on Open Science Grid. So Pegasus have native container support, but on Open Science Grid, you do not use that. And the reason for that is that Open Science Grid provides container support as part of the infrastructure. And it's container support, but it's container distribution and container invocation. And so in your submit files, you would see something like this. And this is easy to set in Pegasus, right? You set a requirement and you set the Singularity image pointer to what container to use. And this is well described on both on the Pegasus documentation and the Open Science Grid documentation. But that's just, for your information, if you want to use containers on Open Science Grid, it's the functionality is there, but it's not directly via Pegasus. And that's all I have. Thank you.